presentation? Fine. So thank you very much, Natalie, for inviting LandCover6k to present our products. We are at the end of the working group, trying to make a kind of overview. Of course, we can't show everything. The list of people that have made this possible over these 7 years now would be incredibly long. So many of these people are in fact present, listening. So thank you all. You are not named here, but I am extremely thankful for all the work. And of course, for all those that are not here, but dispersed in the world. Sorry. So what I want to say immediately is that LandCover6k was from the start thought to produce products of land use and land cover change for climate modeling. So you have to keep this in mind because all our methods and strategies and protocols, they were developed, of course, with this in mind. But these products are, of course, already useful for other questions, and I hope they will be useful for you too and for others in the future. For climate modelers, as many of you might know, if they want to study land use as a climate forcing in the past, they need description of the land in the past and as it was transformed by humans. So the descriptions that they have used a lot and still use a lot are the so-called anthropogenic land cover change scenarios from the HYDE database that is developed by Keys, Klein-Goldewitz. And then there are other such scenarios. Another that is very much used is that of Kaplan, KK10 it's called. There is the one of Olofsson and Hickler. There are those of Pongratz et al. And so on. The problem is that for the same period, you see, 2000 BP, they are quite different in terms of open land. All what is red is completely open, and the yellow colors, it's half open like this, and dark green is forested. So you see it's very different from scenario to scenario. So we know since long that this has to be understand why it's not reacting. Yeah, this needs evaluation, and empirical data are, of course, here to do this. And we are using pollen data and archaeology. The working group has worked into has divided the world into 5 very big regions, as you see here. And we have had all the time 4 main activities. The first ones, and that have taken most of our time, are pollen-based land cover reconstructions. And we are using the reveals model developed by Sugita, sorry. And then we have the history archaeology-based land use reconstructions. We are collaborating with Kees Klein-Goldewitz and Kaplan for the anthropogenic land cover change modeling. And we are collaborating with climate modelers, in particular in the PIMI paleoclimate model intercomparison program. And Sandy Harrison has been our link to this community. Quite recently, 2020, we published the strategy of LandCover6k. So you can read this if you're interested. I will not describe all this in detail. I just want to say that you will recognize this in all our work. There are these 3 parts where the LandCover6k working group work primarily on these products that are from empirical LandCover and land use data that are both pollen-based, reveals LandCover, and archaeology-based land use maps and lookup tables. Then this is used to evaluate, correct especially nowadays the HYDE database that will in turn be used by models, climate models and other type of models like carbon cycle model. This has been a bit lately modified because we wanted also, or we wanted, it happened, or it happens in some projects that we are in fact using pollen-based reveals LandCover reconstruction directly to correct HYDE, or to try to correct HYDE. It's in progress, and also directly in climate modeling. So I will show a little bit of this. I have troubles to get my, for those that don't know about this reveals model, very fast, we use pollen records. It is developed for pollen records from large lakes, but this has been tested on small lakes too, and a small box. If you have many records from those small sites, you can use it also, the reveals model, but you will get larger errors. So the strategy is to use all pollen records that are available and are well dated or enough well dated, and so on and so on. So we have some criteria for this. All of them in grid cells of 1 by 1 degree. To use the reveals, we need also pollen productivity estimates and fall speed of pollen. Then we can get regional vegetation. We have tested that the spatial scale of reveals reconstruction is of the size around 100 by 100 kilometers. It depends of the region, of course, but it's the scale that is relevant for climate modeling. So we get plant cover in percentage cover, and this can be for a number of taxa, for which plant taxa, for which we have pollen productivity, and standard errors. If the standard error is equal or larger than the plant cover in percentage, it is of course that it's not different from 0 and it can't be used. But it's good to have these errors. So it's why I want to tell this, that it's not just a percentage cover, but there is an error that is based on the errors on the pollen productivity estimates and also the variance between the pollen data we are using. The reveals model, it has been validated in Europe and Northern America, and also in subtropical China, and it's in progress in other regions. Oops. So now I speak only of the activity LandCover6k in terms of pollen-based LandCover reconstruction. Chad will talk about archaeology. So here I show the difference, or I show two generations of reveals reconstruction for Europe. So the first one is published in 2015, Tronman et al. It's the one you see in the right little corner. That was based on 600 pollen records, and it was for 25, I think, or 27 plant taxa. The new one is now just submitted in ESSD. Is based on almost double the number of pollen records, 700 pollen records, and it is for 31 plant taxa. The big difference is that it includes the Mediterranean area and a little bit more of the East. And yeah, another very big difference. It's a transient reconstruction. So it covers all the Holocene from 11.7K, while Tronman was just 5 time windows. So you see the cover of sites in this new reconstruction. And here, just to show you one of the representation of this data, you can do in many different ways. This is open land. So this means that we have grouped all the taxa, herb taxa that we can reconstruct with reveals. We have grouped them in something that is called open land. And this is around 3,000, for instance. And you see that we have also shown the error. It's this little circle in the middle. And when the circle, how do you say? If it fills the grid cell, it means that it's 0, or you can't use it. Okay, but if it's smaller than the grid cell, it's a plus minus that you have to take into account, of course. That is more or less large. In 2017, we published a comparison of the first reveals reconstruction for Europe with the deforestation simulated or scenarios from KK and HYDE. And it was shown that reveals was closer to KK10 than HYDE. Then we published the first synthesis over the northern hemisphere of the reveals estimates we had at the time. So it was based on unpublished, but should be soon submitted, reconstruction for all of North America, Canada, and Alaska, and then published reconstructions from China, from the whole of this big Siberia, Mongolia, etc., and the first Tronman et al. Reconstruction. You have also the same reconstruction in the paper by Harrison et al., where we have the strategy of LandCover6k. And I like this picture because you see the difference between 200 BP and 6,000 BP. And the difference, or you mean the percentage, percentage of change, where the brownish is more openness, of course, towards 200 BP, and the bluish less. Then we had for China. Suddenly I realized I have jumped over a slide that gave you the may I go back? Very sorry. How will I do? Okay, like this. Yeah, was this one that I wanted to show also. This shows the state of LandCover reconstruction with reveals. So the stars are the studies for pollen productivity estimates, because you have seen we need pollen productivity estimates to apply reveals, and this is the parameter in this model that is the most difficult to obtain. So the big stars mean that there are a lot of RPP studies and a lot of RPP values, which mean that it's easier to use reveals. And the small stars mean that there are just a few studies, or RPP studies. So you see that it's in the Northern Hemisphere, again, that there are most of these studies. Therefore, it's also in the Northern Hemisphere that we have these gridded reveals reconstructions. In Northern America, as you have seen, in Europe, and so on, until China, all temperate China is done. In the tropics, there is much less done. Now there is a big synthesis of pollen data, archaeology, and so on that has been published by Rob, you know Rob, Marchand, in East Africa, but these are not gridded plant cover and so on. Then there are a few published or soon to be published foreign productivity studies, and a few application of reveals, but only on few sites or single site. There is a synthesis of pollen productivity estimate for subtropics and tropics that is soon to be submitted. So, sorry, it was this I wanted to show you. It was quite important. So now I go back to China. So I will try to go fast because I'm at the end of my time, I see. So a very good collaboration with China. A first synthesis of pollen productivity estimates published in 2018 for temperate China. There are new studies since then, and also in the subtropics and the tropics. The first reconstruction was made not as a gridded reconstruction because there are not so many sites that were appropriate for this, so 92 sites. So these reconstructions were presented and published as trajectories of change over the Holocene for a larger region than just one by one grids. But this can be transformed in a gridded reconstruction that can anyway be useful in climate modeling. And this is soon to be submitted with exactly the same protocol as Europe, Northern America, and so transient through the Holocene. Then climate modelers, they can't use these gridded nice reveals estimate maps. What they need is a continuous data set of LandCover, anthropogenic. So to do this, you need special statistics. So we have two statisticians at Lund University that developed a statistical model and tested them using as their data reveals estimates and then covariates. So the usual covariates are, of course, elevation, latitudes, longitudes, but you can also add other covariates. So they have also tested with adding model simulated climate-induced vegetation, which is natural vegetation, and how the vegetation should be according to a model. or the Kaplan et al. Scenarios of deforested land, or both. So to finish this presentation, what are we doing just now where we are using these pollen-based LandCover reconstructions? There is one Swedish project about Europe that is a continuation of what was published by Strandberg et al. In 2014 in Climate of the Past, where we are studying the effect of land use at 6K, 2.5, and 0.2K using two on the regional climate. So we are using two regional climate models and one global climate model that is always needed for regional climates for the boundary conditions. And with this and a vegetation, dynamic vegetation model, at which you guess we have produced 3 natural vegetation, how vegetation would be without human impact according to model simulations. So it's 2 regional models, as I said, climate models that produces vegetation through the dynamic vegetation model, and then the global climate model also, a 3rd one, and then our reveals-based reconstruction. So this illustration is of course difficult to read because it's the composition in terms of evergreen trees, summergreen trees, bare ground, and open land. You simply see that they are different. So we are doing a sensitivity test, if you want. How do these different vegetation influence climate? Is it very different, not different at all, and so on, significant or not? And how the anthropogenic does influence in this case. I wanted to say also that LandClim2 is used in another project that is a European project, Terra Nova. Maybe many of you have heard about this. So Florence Mazier is involved in this and has done with a PhD student a 3rd generation of the European reveal reconstruction with more pollen records than our LandClim2. Finally, we use this LandCover things in the so-called PMIP, LandCover6k Fast Track Initiative, where we are focusing on Eurasia and using this to correct HYDE, and then to use the corrected HYDE in climate modeling. So PMIP participates in this. So there are several climate modelers that will do runs with the new HYDE Eurasia corrected by our reveals LandCover and the archaeology that Chad will talk about. So now I have to stop. Just my lens ahead. So what we are doing now, we are at the end of the working group. So we fight to publish all of what we have done. And then to put this in open access. So Pangea and Seed, I don't know if you know this pollen database that is developed in Umeå in Sweden by Phil Backland. And we begin to use these products according to our strategy from the beginning. And we want, of course, to integrate land use and LandCover datasets that we have produced. And this is already in progress for Europe and China, and we will develop this in the coming years. So sorry, I have been longer